a few tasks using GIS. We're going to learn a bit about geodatabases and, of course, the data model, which we've titled the ArcGIS Public Garden Data Model. It used to have a really long name, Botanic Garden and Zoological Park Data Model, but we just dropped that and changed it to Public Gardens. We do have things in there for zoos. Zoos have a lot of similarities to gardens. So we have some things in there for like animal enclosures and things like that, and I'll talk a bit about that. Is there anybody here who's a zoo person? Okay, great. And then we're going to learn a little bit about heads-up digitizing, which is basically a term for just basically using an aerial photograph on your screen and digitizing features off of that, which is basically creating polygons for buildings or roads or things like that. And then, as I mentioned, we'll do the mobile device data collection, and then create some plant collection maps. Actually, one more thing here is I wrote on your agenda that in this kind of format, when we have just a full day to do it, we're not going to be able to learn how to do everything required to get a GIS started. But I wanted to expose you to all the steps along the way, so that when you actually go back and try to do this stuff at your garden, you know the general process and you've seen some of the skills. And because we're going to be recording this today, you could go back to the video and reference that. So I wouldn't worry about taking really detailed notes, because you can always go back and visit. Just try to stay with what we're doing, and you'll get the general idea. And then I'll point out some other resources that are available for you guys to continue. Okay, so I want to talk a little bit first about what is GIS. So basically, GIS is all about geography, and a lot of people ask, what exactly is geography? And geography is really about 3 W's. It's about what is where, why is it there, and then why do you really care about it? And an interesting statistic is that about 80% of all data that's out there has a spatial component. So that's really interesting to think about, is that most of the data that's out there in the world can be visualized in a GIS system. GIS is kind of defined as a system of computer hardware, software, personnel, that to help manipulate, analyze, and present information that is tied to a spatial location. A lot of people think that GIS is the same as GPS, and it's really not. GPS is all about global positioning systems. That's using satellites to find your location on the Earth, where GIS is really that system that is mentioned in that definition. GIS is also not a static map or a paper map. So if you get a PDF map or a paper map in your car, that's not GIS. So GIS may have been used to produce that map, but it's not the same thing. And GIS is also not a software package. You use the software to create and manage a geographic information system, but the software itself is not GIS. So another good way to think about it is that GIS is a method for visualizing, manipulating, analyzing, and displaying spatial data. I like this analogy that GIS is kind of a smart map, where basically you have a map that has data connected to it, so that when you see a feature on your map, maybe it is a roadway that you're going to be taking. In a GIS, that roadway has information about it. When was that roadway last paved? How many lanes does that roadway have? What's the speed limit? All those things it's the connection between a database and a map that makes GIS so cool. And databases generally are hard to interpret. If you ever just look at a database, it's generally a table, right? You got rows, you got columns, a bunch of stuff filled in there. And it's really hard to be able to decipher what that information means without running some kind of report or doing some kind of analysis on it. But GIS lets you look at that database in a visual fashion, so you can easily see patterns in the data and very quickly, and it makes it a lot easier. I'm myself a really visual person, so I instantly gravitated towards GIS when I first saw it. And GIS generally can combine data from many sources, so you can have all kinds of different things in there, all laid on top of one another. So you could have information about roads, you could have information about buildings in a city, you could have information about open space, and where the water is, and all that stuff, and look at it all at once. The original, start of GIS was they were taking kind of like clear overlays and drawing information on there and laying it over the top, and you can instantly start to decipher patterns off of that. And it's kind of the foundation for GIS. So GIS data comes in two main formats. One is the common one that I tend to use the most is vector data or linear data, and that we usually think of that as being points, lines, or polygons. And the image at the bottom there is kind of representative of what vector data is. And vector features are usually represent things like houses or lakes or really discrete objects. And those features usually have attributes, as I mentioned, tied to it. So you may have information about the size of something or what type it is, length, etc. And then the other type of GIS data is raster data, which are basically a grid that has a location. So each cell in that grid has a location, and then it also has a value associated to it. So in the case of an aerial photograph, each location or pixel in the photograph has a location on the Earth, and then it has some value of basically light, the reflectance of light. So it's basically giving you a color. So it's giving you green for trees or gray for a sidewalk, and you put all those pixels together, and that makes an image that we can interpret. Satellite data is also raster format, and sometimes we use other data called elevation surfaces that kind of show topography. Those are generally in raster format. And then if you're doing some analysis work, a lot of times if you want to do maybe a suitability analysis, say you want to find the best spot for a wildlife corridor, you would do some kind of analysis where things get weighted and it shows up as hotspots, basically, is that you get areas of higher value that are more suitable for putting that wildlife corridor. So where does the GIS data actually come from? You like that picture, man? The top picture is from one of our students that was helping us collect data when we first mapped our collection.
Prehistoric times.
Yes, prehistoric times. So where does GIS data come from? A lot of original GIS data came from digitized paper maps. So there would be paper maps, and you would scan those in, and then you would basically digitize those and turn the lines on the map into line features in your GIS. Non-spatial databases, so a lot of people had information, and maybe you had a plant record system, and maybe you had some coordinates in it. Maybe you had coordinates for where your plants were, and you could actually take that non-spatial database and turn it into a map-type GIS database. GPS is one of the main ways to get data into a GIS these days. You go out with a GPS data collector. It uses the satellites to locate exactly where you are on the Earth, and then you can record information about that point. Maybe it's a plant, so you can take the GPS location of that point and then attach information such as your taxonomy, size information, and other things to it. Another common way is for field sampling, and this relates to GPS in some ways, but sometimes you can go outside and just walk up to a tree maybe, and you're not getting the exact location, but you have some points of reference and on there, and you would just want to actually record information about that tree. So that's another way you can do it. And then, as I mentioned before, remote sensing is a big one. So satellites or planes. And remote sensing is basically just taking information about an object from a distance. So with anything, a camera is a remote sensor. Your eyeball is a remote sensor. So basically, remote sensing is that we're taking photos from a plane. Aerial photography is a really common way, or satellite imagery from a little bit higher up. And then another way is surveying, is actual traditional surveying equipment. They can go out, surveyors go out and use points of reference to capture the locations of things very accurately, and then you can bring that information into a GIS. So common uses for GIS. Emergency services are really big on using GIS. Fire and police departments can find the quickest routes to be able to get to some kind of emergency and be able to monitor where their vehicles are out in the field and things like that. Environmental is a huge use for GIS. A lot of environmental monitoring, a lot of modeling is done with that. So, I used to work on river systems, and we would model basically the way that the river would meander over time, and we could use that information to be able to create a predictive model to say where the river is going to go in the future, so that you can try to use that for flood control and things like that. Businesses use GIS a lot to determine maybe the best location for a business, so you can use demographic data to find out where your customers are, and then maybe find a street that has the most traffic on it, put that information together to put your store at the optimal location. And then they also use it a lot for delivery systems. So like UPS uses it to basically route all their vehicles to be able to find the most efficient way to get from point A to point B. And then it's used a lot in lots of different industries. Transportation industry uses it. Communications, telecommunication stuff, it's really important. Where's the best site to put a new cell phone tower? Mining and pipelines, so where are you gonna put your oil pipeline? What's the best way to get that from point A to point B again? Even healthcare, I've always thought this is an interesting one. The hospitals use it to actually manage what's going on in each room, who's in each bed, and what's the best use of that space, and where's the best spot for doctors to be able to get to all those patients. Government is probably one of the biggest users of GIS, and it's used on all levels of government: local, state, federal, even the military. The military especially uses it for all kinds of things that I care not to talk about. And then finally, in education, it's a great teaching tool for students. As I said before, visual learning is it's the way to go, and people understand things a lot easier when you show them an image of it. And then it's used a lot in research for a number of different applications. All right, and that's pretty much it for my brief intro to GIS. Do you guys have any questions?